Hey, everyone. My name is Sindre. I'm from Oslo, Norway. I'm going to do a talk today on moving beyond virtual DOM and state management. Yeah. This is my first talk ever at a conference, so I'm a little nervous, but let's hope it's going to work out fine. I'm co-founder of something that's called Scrimba.com, which is an interactive screencasting platform. And I'm also the creator of a language that's called Imba, which I'm going to show you some parts of today. So first, I'm not sure if any of you have heard about Scrimba, but I'm just going to show you for like 2 minutes what it is, because it's actually pretty cool. It's a new sort of screencasting technology. So we have open courses. Everything is free. Here is a React course. I can go into a video, and you can basically just scrub around and see the presentation exactly as you would with a regular video. But you can also jump in and pause the screencasts and jump into the code and change stuff, see how that affects the examples that the presenter is actually teaching you, move around, look through the different files, etc. And then when you think you understand stuff, then you can just continue watching the thing. And you can record your own screencasts in this technology as well. This whole platform, front-end and back-end, is written in the language that I'm going to present. Just another plug, we're also having a stand out there by the name of GitSpeak, which is the business version of Scrimba, internal tool for teams. So be sure to just come on over and chat later if that sounds interesting. So, the beginning, or it's not the beginning, because jQuery and the imperative way of doing stuff was really the beginning of real web applications. But over the last 5 years or more, almost every web developer has started creating applications in a declarative manner, like with declarative rendering. And what that means is that these frameworks now allows you to basically describe how you want the whole application to look, or how you want the page to look, based on some state of your application. So you're not responding to events and mutating the view directly. You are rather just declaring, this is how I want it to look, depending on any state. And then the framework will take care of the magic for you. Because the obvious problem with this is that you can't just re-render and recreate the whole DOM on every update. You can't basically replace the whole page every time something happens. So people have tried to come up with some clever solutions to work around this. And by far the most well-known solution, which was introduced by React, is called a virtual DOM. So instead of re-rendering the page itself every time, it will basically request a new virtual representation of your page, and then it will take that virtual representation, match it up to the previous virtual representation, and find out what parts it needs to change in the real DOM. Because their assumption was that the real DOM is way too slow, and that this is the best way to actually apply the changes. And the process of making the view sync up with your data is called DOM reconciliation. So that is the concept of trying to find out what has really changed and applying that. And the main question that I'm going to ask throughout this presentation is, what if DOM reconciliation was infinitely fast? Like, how would that change the way we create applications today? Would it allow us to start working in almost kind of a new paradigm? That might be. So what if DOM reconciliation is really slow? Because that's the state today. It actually is really slow. Originally, React was sold as a really performant thing, and it was sold as like the virtual DOM was a fantastic solution to this. It's just blazing fast, so you never need to care about how you render stuff. And that turns out not to be true. I don't have a presenter screen here, so I don't really know the next slide, but I'm hoping. So the thing is that to make sure we can do this declarative rendering, even while the DOM reconciler is slow, we need to follow some strict rules. And you might not think of them as rules today, but they really are. And we don't want to sell you these ideas and tell you that you need to do this to help the poor virtual DOM, which is way too slow. We want to sell it to you as a grand idea. We want to sell to you that this is the best way to make applications. This is the only way to make them bug-free. And so we need to make sure that you believe that it's actually good for you to do these things, to use these patterns. And I'm not saying it's not good, but I'm saying you should have a choice when you develop an application of what way you want to manage your state. So the first lie, the first thing we really need to get all of you to believe is that bidirectional data flows are just bad for everything. We need you to believe that everything must come from the parent and down in a strict hierarchy. And the real reason for this, for doing this, in my opinion, is to help the poor virtual DOM that doesn't really know about changes if they happen far deep into the hierarchies. So if the virtual DOM is not able to see that, oh, no props have changed here, so nothing will have changed deep down in this tree, then it basically doesn't work, because doing all those checks for itself is too slow. And the next thing we need to sell, which is, I could do a whole talk on that, it would be a huge rant, but still, is the concept of mutability. And we've all learned that immutability is basically the only way to make sure our application isn't exploding and crapping out all sorts of stuff. Because mutability is just the root of all evil, basically. And before React, before the virtual DOM, I don't think more than like 5% in the JavaScript community even knew what immutability was. And the truth is that immutability is a relatively ineffective and very, very complex way of helping the virtual DOM know when something is changed. So if someone here in this room raised their hand, and there's a painter here who wants to just keep everything up to date and repaint the room every time something happens, then if he was the virtual DOM, he wouldn't notice if anyone raised their hand, because it's still the same person. So the genius behind immutability is that you would take that person, throw him out of the room, clone him, raise the hand of the clone, and put him back in the room. But that wouldn't help either, because the virtual DOM is sitting in the corner and just like, it's the same room, so it's probably nothing has changed. So then you would just need to reconstruct the room, take all the people, clone them into this room. You get to keep the same people. That's a huge benefit. But you replace the one person who raised his hand. And voila, the painter will now see, something is changing in this room. I think I will try to re-render. But this process is very slow. But if you subscribe to it, then it's OK. But you need to follow some strict rules. I'm going to show you a world where you don't need to follow these rules. And right now, it's pretty chaotic. You need to make sure you don't shoot yourself in the foot or other places. I think it's pretty accurate, actually. The amount of people who's standing there is about the size of this community today. So there are some issues. But we are solving the DOM reconciliation in a totally different way than a virtual DOM. And the performance is, to say the least, better. A lot better. So first, I'm just going to drag you through this language like very, very quickly. It was started, we've been working on it for 8 years now, I think. I've been using it internally for a lot of projects. I'm not good at writing documentation. I really hate it, so I started a bunch of different projects instead. So it's been open source for a few years, but hasn't really taken off. And there are many reasons for that. It's a new language. It will look strange to most of you, especially if you don't come from Ruby or Python, which is heavily inspired by. But it supports all these basic things that you will have in a language. And it also has the concept of DOM tags as a native data type, or a primitive, like a first-class citizen in the language. So that's kind of like JSX, but it works at a much deeper level. So you can instantiate tags. We have again, it's very, very tailored to create web applications. So the language has a lot of shorthands for doing the things you will often do in these applications, like applying class names, applying conditional class names, like this. So this P here will render with the class name red if this condition is true or truthy. And you can define custom components like you can in React, but it's at a very deep level a part of the language itself. And that includes the fact that you can, let's see, tag syntax. So you can have conditional rendering, like it's all part of the language. So inside of your whole render trees, you can have conditions. You can obviously render lists, like loop through things and render lists. It's all indentation based. So many of you will not like that. I love that. But when we compile these tags, like this component here looks kind of like a React component. It is basically has a render method, and this render method says that within this tag component, we should have an h1 and a p with these class names and these texts. And when we compile it, it looks something like this. And this code is relatively easy to understand. It's not how you would write JavaScript yourself, I guess, but it is easy to understand what's going on. And the first part of the performance already comes here, and it might not be apparent. And that is, instead of gathering all the properties and details about a tag in an object, we actually apply each part, like each property or class name or anything, in a chain of setters that mutate this object. And these tiny methods, they know what they are supposed to do. The JavaScript engines are really good at inlining these types of functions and optimizing them. And the other thing is, when you start doing dynamic stuff, then we actually split up the creation of DOM elements and their properties and the updates into two separate logical branches. And this is happening in the compiler. So when you write this view, it's basically just an h1 title, welcome, and a paragraph, which has a class name red. Half of the time, it's rendering. This is what that compiles to. We set the children, set the class name, set the text, and we set a class name red if something is true. But if you look closely here, when we call render the first time, then this will happen. Like we will create this, and then it will add the class name. But the second time, all the static parts are already cached. So it will basically skip this whole part here, and only do a single operation, which is toggling the class name red on the paragraph. So this concept is actually very simple. It gets way more messy when we start introducing conditional tags and dynamic lists and stuff, but it's still depending on the same core idea. And that core idea is very different from the virtual DOM, because we are working directly with DOM elements. So instead of trying to spend the rest of this talk trying to show you Imba and all the quirky syntax and trying to convince you that you should start using this now, I'm not trying to convince you that. The documentation is shitty and all of that. But if you're curious, it is a joy to work with in large applications, at least for us. So when we usually benchmark things in the web world, we test things like, how fast is it at creating 10,000 to-do items and removing them in one single operation? Or how fast is the framework to do a lot of mutations? And those benchmarks are okay, but they mostly test the performance of the browser. Because there are so many actual DOM operations and actual mutations happening that you're no longer testing the core DOM reconciler. And my point that I'm trying to convince you of later in this talk is that that is by far the most important thing to measure. Because in a regular application, in the real world, the most common scenario is that almost nothing is changed. Maybe a single tiny thing will change its title, or a to-do item is suddenly marked as done or not. And if the DOM reconciler is fast enough, if it is infinitely fast, then we could potentially just re-render the whole application from root every single time. We didn't even need to worry about whether the data has changed or not. We just re-render every time, and then we can know, we have a guarantee, we know that the view will always be in sync with your state. And you would not need any sort of observables. You wouldn't need to listen to when the data has changed. You wouldn't need to do the approach of mobx and similar, which I love, by the way. You could basically just work with plain data for your state. And in this benchmark here, which is an implementation of the to-do MVC example, like the reference example, for IMBA, for React, and for Vue, where we have a shared library that takes care of mutating the state. It's actually mutating. It's not creating these weird immutable structures. And we're forcing each of the implementations to basically do a full DOM reconciliation. We give them a new state, and we say, you're not supposed to know whether anything has changed or not. Just make sure my whole view is up to date after I force you to do that reconciliation. And it's deterministic, so when I step through this, you will see that the end state after the same amount of operations will be the same in each example. So this is just stepping through. But if we try to run this, so IMBA is using this memoized DOM technique. React is using the virtual DOM. Vue is also using essentially a virtual DOM. They have some promising new improvements in version 3, which I'm looking forward to try out. But when we try to run this benchmark now, we're basically just trying to get as far as we can in these iterations and see how many full DOM reconciliation iterations we can do per time unit. So if we start with IMBA, we see that we are now past like 500,000, a million operations, like 208,000 operations a second. React, we ended at 8,700, and Vue, I guess a little lower at 7,700. So when I try to convince people of these benchmarks, the obvious first objection is that I'm an idiot, that I don't understand what I'm testing, that I probably confused and messed up something about asynchronous rendering or synchronous rendering, that I don't understand that one of the one of the frameworks is batching stuff and the others are not. You are free to think that, but I've been working on this for almost 8 years now. It is not the case. I do actually know what we're testing. And again, I would claim that this type of benchmark is the most important thing to test DOM reconciliation performance. And I would even say that there is one kind of test that is even more important. And that would be how fast the DOM reconciler can reconcile this if there were no changes at all, as I talked about. Because if it's really fast then we can start rendering on every frame. We can start rendering whenever we think something might have changed in the application and just don't worry about it. So we can remove all the observables and all that stuff. So if we run that kind of benchmark, just doing 100,000 iterations where we don't change the state, but neither do we let the reconciler know that nothing has changed. So it has to find out itself. We're not helping it with should component update or a crazy immutable framework or using like some sort of weird data state management system. So this is a flame chart for IMBA doing these 100,000 iterations. It does it in less than 100 milliseconds, and it spends around 5 milliseconds in garbage collection. This is the React version of the same thing. It takes 8.3 seconds. It's over 80 times slower. And it spends more time doing garbage collection than IMBA spends doing the whole thing. And I think that is actually pretty important. Because I'm not suggesting that the real-world performance difference of IMBA and React in a regular application today is huge. That's not what I'm suggesting. I'm suggesting that this real-world performance improvement, which is real, lets you develop applications in a different way, which is simpler. This is the same thing for Vue. You can see in these flame charts the complexity. Like, you see a hint of the complexity behind the diffing algorithms and what's going on behind the scenes. You can see that Vue is even crazier, but Vue also has a lot of built-in key-value observable stuff. So that's kind of natural. But as I said, the objection after I've been arguing with people for like a few hours about whether the benchmark is really cheating or not, the new objection is obviously like, React is fast enough. There's no reason to use this. And to that, I would say that it's fast enough until it isn't. So even today, your application would not become 20 times faster for the user. He wouldn't feel that the button is clicking 20 times faster if you rewrote it in IMBA. But I'm saying that the app could truly be 20 times more complex. Your views could be 20 times more complex or larger before you start running into the same performance bottlenecks that you might run into with, say, React today. And the problem with that is, as long as your example is, as long as your application is fast enough that you can basically reconcile without it degrading performance, then it doesn't matter what you use. Like, every framework will be good enough. But when you start running into these problems, when you start running into the problem of the reconciler being too slow, like you're rendering a list and it's actually lagging when you change a page or doing whatever, then you're in big trouble, because the only way you can resolve this is you will start to need to restructure your application. You might either need to change your state management framework to something that is more efficient, more granular, that manages to track the changes more efficiently, or you might need to start introducing should component updates and just do a lot of work that I think the DOM reconciler should have been able to do in the first place. So again, it doesn't really improve user experience that much. This is a very fancy graph showing the experience of users and improved rendering performance. There's a ton of research behind this. So my hypothesis is that it doesn't really matter that much to users, but sometimes there will be like a huge bump in user experience. And that will happen the times when performance has improved enough to be able to kind of change paradigms. Because then the developers are able to create better and larger applications and are able to spend more of their time building great user interfaces, great applications, and less time on solving weird bugs and trying to make sure stuff is working efficiently. So my point here is that with raw DOM modifications, imperative rendering that we did before, things were working okay. But for the developer, things became massively easier the moment we could jump over to something like declarative rendering with the help of the virtual DOM. And for a long time, so people have created virtual DOMs that are getting relatively efficient. Like, in that constrained type of technique, people have created virtual DOMs that are much faster than React's. But React is still fast enough for most of this stuff. It is only when you get far enough, when you actually get to that 10x, 20x, maybe 50x performance, that's the moment when you can actually start doing things in a different way. And I call that careless declarative rendering. And that's basically just the same thing. You're doing the same thing that you did in React, but you don't really care about how you manage the state, or you choose a state management framework that suits you, not one that suits the virtual DOM. So I actually think that I talked way too fast, and that I'm basically at the end of the talk. But if you have any questions, I could rant on about immutability, if anyone wants that. Or I could take some questions. So, do anyone have any comment or, yeah? So the library footprint size is 57 kilobytes. Around that, I don't remember exactly now because we're at 1.4. So it's a little smaller than React and most of the others. The funny thing is that this memoized DOM concept is actually much, much simpler than a virtual DOM on a conceptual level. Like, it wouldn't be too difficult for you to understand it. So it requires less code as well. Yeah. I gotta go. No. Yeah. So I actually got a phone call now. No. So one good thing about it is that Imba compiles to accept the tags in Imba. The rest of it compiles to relatively clean, regular JavaScript, and it's fully interoperable. So you can both export, as long as you compile the Imba files, you can publish an NPM package that is going to be used in the regular JavaScript system. And inside of Scrimba, we obviously use a lot of regular NPM packages from JavaScript. So it's kind of like CoffeeScript in that sense. So you just use the same ecosystem. Yeah. Yeah, I didn't know about it until a few days ago. Yeah, I think so. As I saw it, and I also think that the next generation rendering in Angular is also doing some kind of the same. Yeah. Hey. Yeah. And to be honest, like, I've been working on Imba for a long time and been using it for a long time, and I'm not naive. Like, I'm not expecting everyone to pick up this new weird language with all these things. So I would be extremely happy if some of the bigger frameworks took these ideas from the memoized DOM and used them themselves. Because it would be very cool if more than 10 developers could get the benefit from a very, very new, basically a revolutionary new way of doing this. And maybe it's just time now that there will be others that start coming out with using the same concepts. To be honest, I was just shocked about the performance myself, because I didn't really intend it to be that fast in the beginning. It was more like, this is the way it makes sense to do it in Imba. And for the first few hours after I wrote the first UI bench implementation, I spent the time trying to understand why I was cheating and how I was cheating and all of that. Yeah. Yeah. So the main reason is because it's an old language, not a new language. Like, today, I might not have started writing it, but whenever I go back to React, I'm very glad that I did. But at the time when I started, the ecosystem in JavaScript was just totally different. Like, it was crap, and I came from the Ruby world, and I loved the simplicity there, the elegance, and I wanted to replicate that in the browser. So yeah, that's the reason. Yeah. Yeah, so that's the thing. Imba is fully agnostic when it comes to state management. So you could definitely use, if you, for some extremely weird reason, wanted to use Redux again, then you could use that in Imba, definitely. And you can absolutely use MobX if you want to do that. On the data side, you often do need some sort of framework to cache expensive computations in the business layer. So it makes sense to use with some other things. But it also has similar things like should component update to match React. We've never used it in Scrimba. And it's actually kind of funny, like the thing you see here in Scrimba, this is re-rendering the root of the whole application on every frame, or whenever anything is changing. Like the time, where the timeline is, the lists here of files, everything like that. And it's actually working pretty well. Yeah. No. So I've been thinking a little bit about that. I thought that at least in a framework like Vue should be able to compile their views in a similar manner. But I saw on Twitter that Evan Yu said that it wouldn't work because they support this render function thing. I know for a fact that a framework like React wouldn't be able to, just because it uses a very different way of thinking about these concepts. Like in the virtual DOM, when you call render, you're basically not mutating anything. You're just returning a description of how you want something to look. But I do think it would be possible, or it might be possible, to create a JSX compiler, or basically a JSX plugin that could compile the JSX tags to something similar, and that you could create a JavaScript framework on top of that. Because I could basically recreate the tag system from Imba in JavaScript in an hour. Like the ground core of it. You just need some lightweight DOM wrappers. You need setters for the different types of properties you want to set, and yeah. So it could be possible, and it would be very cool. Yeah. So, to be honest, I started trying to make Angular work with this kind of benchmark. But in the end, I understood that it doesn't really make sense, mostly because Angular has like a crazy complicated way of doing DOM reconciliation by tracking changes and stuff. And that's totally fine. But for me, it just seemed so backwards that I couldn't really wrap my head around it. But as again, someone pointed me to Angular Ivy, which is the next generation rendering engine. And they are using something that I think looks kind of similar to this for very performant rendering. Mm-hmm. Yeah.
When you have a change deep down, for example,
yeah.
how do you detect that has changed?
Yeah, so that's the exact thing. You don't detect it. You don't care about whether it has changed. The only detection you need to detect something. So either you need to just re-render on every frame, just say, now you just need to get it in sync. I was doing that for a long time. Now I see that, it's probably not necessary. So now the default is that we just re-render on every DOM event that has been handled. And when you use some server-side thing to fetch data and stuff like that, you will, in a few places in your code, need to call imba.commit, which is basically just saying, beware something might have changed. You should just try to get it all in sync. Yeah. Cool. So again, if you have other questions or want to check out Scrimba and GitSpeak, me and my co-founder are here, having a huge stand with tons of stuff. No pinball game. Yeah. Yeah, that's a good question. So let's increase this to first to maybe 20. Let me see if that. If you reset this, now there are 20 items here. So reset this, run the benchmark. My guess is, I don't remember, but my guess is it's about the same different. It might even be a little faster, but I'm not sure. And my guess would be that it is faster because it's basically like the more stuff you're trying to, yeah, it's actually faster, yeah. Cool. So that's the talk. I almost spent the time. Thank you.